Solve another Leetcode problem, 1191, K-Concatenation Maximum Sum. So for this problem, we are giving an array at an integer k, and we're going to modify the array by repeating it k times. So the modify is going to be easy. So for example, if we have an array 1 to 2 and k is going to be 3, and we're going to just repeat it 3 times. So it's going to be 1, 2, 1, 2, and 1, 2. So this is going to be the final array. So we're going to return the maximum subarray sum in the modified array. As we can see, this is going to be a maximum subarray problem. But the problem is that the k is going to be a really big value. So for example, the length of the 3 is going to be 10 to the power 5, and k is going to be 10 to the power 5. So if we use the brute force of maximum subarray sum, it's going to be 10 to the power of 5 times 10 to the power of 5. It's going to be 10 to the power of 10. And this is going to be time limit exceeded. Yeah, so this means we cannot solve it like that. So we're going to solve this problem by using the DP solution. So for the maximum subarray sum, actually it is a DP, but because of this value k is really big, so it's going to be time limit exceeded. So currently we're going to reduce this k. Actually, the final result is not dependent on how big the k is. Yeah. So for example, if k equals to 3, so what's going to happen for k equal to 5 or k equal to 7? Do we need to use this array times k to get a longer array and then calculate the final result by using the maximum sum? Actually, we don't need to do that. If we analyze the value of k and find the different cases, normally we can solve it by using the O(n) time instead of n times k. So let's just try to use some examples. So for the first example, so for example, it is 1, 2, and 1, 2. So if k equal to 3, so the final result is going to be 3, 1, 2. So it's going to be 9, of course. Yeah. So this is one case. So if everything is okay, and the sum of the array, for example, is 3, if it is more than 0, so the final result, it can be 3 times sum of the array, 3 times 3, but it cannot be like that. So this is just one possible case. Yeah. And this is the first example we can check, but we didn't find what kind of a formula or what kind of a pattern we can use to solve this problem. And now let's just check the second pattern. Maybe by using the second pattern, we can find by using the second example, we can find a pattern which we can use to solve the problem. So if the array is like 1, minus 2, and 1, now we have another 1, minus 2, and 1. Let's just analyze the array as k equals to 2. So for example, if k equals to 2, what's going to happen? So it's going to be 1 minus 2, 1, and 1 minus 2, 1. So what's going to be the maximum subarray sum? Of course, it will not be 0. From here, it is 0. But from here, this one and this one, it's going to become 2. Yeah, so this seems if k equals to 2, the final result is going to be 2. But currently, this k equals to 5. But if this k equal to 5, this means at the right side, there's still another 1, minus 2, and 1. But what we can do is that we cannot connect them together. Maybe here is a connection, the maximum is going to be 2, and here is another connection, so the maximum is 2. But we cannot make it bigger. Yeah, we cannot make it a bigger value, because from here to here, it is disconnected. We can only choose one of them. Yeah, so this means if the value for this k, if it is too big, so for example, if it is more than 2, but at least we can find a maximum sum by connecting two arrays. So 1 minus 2, 1, and 1 minus 2, 1. It can be a maximum value. Yeah. Or it can be the total value. Yeah. Or it can be the total value. In the first example, so for example, 1 to 2, it can be the maximum value of this 1 to 2. The sum of them is 3. And 3 times k, so it can be a 9. So for this 9, it can be dependent on this k, or the values can be the sum of the concatenation of the two arrays. Yeah, but how can we calculate if this k equals to 5 actually? So actually the formula, the sum of the two arrays, we can get a result. Yeah, so the sum of the two arrays, we can get a result, it is 2. So this is the concatenation of two arrays, so the maximum subarray going to be 2. So this is of course. But if this k equal to 3, so we need to plus another value. It's going to be 5 minus 2, it's going to be 3. Yeah, so we need to plus a 3 times another value. So another value is the total sum of this array. But currently this array is 0. So it seems 3 times 0. But if this total sum of this array is 1, it means 3 should times 1. So this is going to be the total sum. Yeah. Maybe let's just use another example to explain how it looks like. So now we're going to use a better example. So if we have a value like minus 2 and 5, if k equal to 1, it is just minus 2 and 5. So the total sum going to be the maximum subarray sum, it's going to be 3. Now if we have another one, 2 and 5, so what is going to be the final result? So of course it's going to be from here to here. Yeah. So it's going to be 12. Yeah. But what if we have another one, 2 and 5? Let me just remove it from here. So if we have another 2 and 5, what is going to happen? Yeah, it is a minus 2 and 5 because we just need to repeat this minus 2 and 5. Yeah. So if we only have minus 2 and 5, the result is going to be 3. So if we have minus 2, 5, 2, minus 2, 5, and this 5, so the final result is going to be this 5 minus 2 plus this 5 is going to be 8. Yeah. So this seems if the k equal to 2, it can be the sum of them just between them, between the concatenation. The concatenation can become a maximum sum. But what if the k equal to 3? So it seems from here to here. Yeah. So how can we calculate like this? Maybe we have another minus 2 and 5, the k equal to 4. Yeah. So from here to here, so this is a array times 2. So from here to here, we have a maximum subarray sum, it's going to be 8. Yeah, as we can say, it's going to be 8. But from this left side here, this left side, and that right side, we can also get some other values. So those values are going to be minus 2 plus 5, it is 3. It seems 3 need 2 times 2. And it is 6. And 6 is going to plus a value from here, it is 8. Yeah, so it means the final result can be 14. Yeah, I think that's about what we needed to calculate for this kind of solution. This is the left side. This can be the right side. Yeah, if this is not clear, maybe we're gonna do it like this. This is a minus 2 and 5. We have another minus 2 and 5. And continue, we have another minus 2 and 5, and minus 2 and 5. So from here to here, we have a value of 8, because from this 5, minus 5 and plus 5 is going to be 8. But from the right side, we can continue to use this minus 2 and 5, another minus 2 and 5. It's going to be 3 times 2. Yeah, because in this way, it's easier to see that everything going to be connected. It's going to be a subarray from this 5 to this 5. So the total value going to be 14. 8 plus 6 is going to be 14. Yeah. So this is why if the k is really big, so what are we going to do? We're going to check the total array sum. If the sum of the array is more than 0, we're going to use this kind of a formula. But if it is less than and equal to 0, it's going to be the third example. We just need to choose a 0. Yeah, because for this minus 1 and minus 2, the total sum of the array is going to be less than 0. But if it is less than 0, we're going to choose the case which is going to be 0. Yeah, so it is said the subarray can be 0. So this means we will not choose a negative value. So instead of that, we're going to choose a 0. Yeah, now let's just come to the solution. So we're going to define a subarray sum. Let me use a maximum of subarray sum. So this will be calculating the maximum subarray sum. So we're going to have nums. Let's just write this kind of a DP solution. So we're going to prepare going to be length of the nums, and then we're going to check the from 1 to n. So we're going to update the nums I. It's going to be the maximum of nums I, and nums I minus 1 plus nums I, and finally we're going to return the maximum of nums I. Yeah, but we need to prepare 0. I mean, if the value for this maximum subarray is a negative value, so we're going to choose a 0 instead of a negative value. So from here, we need to use a star with nums. So in this way, we calculated the maximum subarray sum. Now, what are we going to do? We're going to check the value of k. So if the value of k equals to 1, this is okay. It is just the subarray sum case, so we just need to return this value. So the maximum subarray sum with the array. So this is going to be the first case for k equal to 1. But if it is not, so first of all, we're going to prepare a total sum. It's going to be the sum of the array. And then I'm going to use array 2 as the concatenation of two arrays. So it's going to be array times 2. And I'm going to prepare a result. It's going to be the maximum subarray sum with this array 2. Now I want to check the total value. So if this total this total is more than 0, so we're going to use the formula. So it's going to be k minus 2 times the total value, and it's going to be plus a result, and the final result going to modular a mod. As the value can be really big, so let me just prepare a mod. It's going to be 10 to the power of 9. 10 to the power of 9 plus a 7. But what if this total is just less than or equal to 0? So if this total sum is less than or equal to 0, so we're gonna choose the result. So in this example, it is a -1 and -2, but the result is 0. But we can have some other values. So for example, we're going to have a -5 and 2, so the total sum is going to be less than 0. But what about k equal to 2? So the subarray sum, let me just just use this example. So the total sum of the array is, if it is less than 0, in this case it is -3, it is less than 0, but the subarray sum can be 2 if k equal to 1. Yeah, so this is why if this k equal to 2, we have another -5 and 2. Yeah, but we can also have other cases. So for example, 1, -5 and 2, and 1, -5 and 2. So what's going to happen for for the maximum subarray? So the total sum of the array is going to be less than 0. So this is okay. But the sum of the two arrays, the concatenation of the two arrays can still be the maximum value, because from here to here, this 2 and 1, it's going to be 3. 3 is going to be more than 2, so this is going to be the maximum value. This is why we're going to use a result modular the mod. So this is result going to be the concatenation of two arrays. Yeah, so this is for the case when this k is more than 1. So in this example, yeah, I think there's a lot of an analysis about the value of k and the total sum of the array. Now let me just run it to have a check. So as you can see, it works. And now let me just submit it. As you can see, it works and it's pretty fast, and the time complexity is ON. I think the difficult part is this is not difficult. We're just calculating the maximum subarray sum. So the difficult part is about checking the value of k and the sum of the array. So this k equal to 1, this is just the normal case. We can just calculate it using the maximum subarray sum. But for this total value, if it is more than 0, so we're going to use a formula. Yeah, because some values in between, this is an array, this is an array, but some values in between, it can be the maximum subarray sum. Yeah, but since this total sum is more than 0, we can also collect other values from the subarray. That is also possible. But while we are calculating, we're going to use this kind of strategy. So this is just the subarray. So we're going to take a value from here. This may be a bigger value, and then we can concatenate all the other values. Yeah, maybe you think this is disconnected. Actually, it is not. Yeah, by calculating, actually they are all connected. And another case is for the total sum. If it is more than, if this total value is less than or equal to 0, we can directly use this result modular the mod, because it is still possible with two arrays. In between these areas, it can be the maximum sum. Because for other values, if we want to collect it, it is a negative value. It is not necessary to collect all other values. We just need to check the maximum subarray sum of two arrays. Yeah, this is for the final result. I think that's all for it. Thank you for watching. See you next time.